Hello everyone, welcome to the second session of CFD post tutorial. In this session we're gonna learn some helpful tools for post processing. We begin with the location part. As you can see, there are some options to create a location, including point, line, plane. We have used some of them in previous session, but we're gonna cover them completely this session. The first one is point. If I create a point, then like always there is domain, and as I've said before, we almost always use all domains and then define the desired method and coordinates. The first method is xyz. It's obviously asks you for the x and y and z coordinate. If I define a value for them, for example, and then apply it. If I just hide the shell and tube, then you can see that there is a point, a yellow point at the bottom of the shell, but I can change the color. Just pay attention that most of the settings of different tabs like color, render and view are the same, and we skip it because we discussed about them before. The second method is node number. You need to enter the number of the node, the node when you created the mesh grid, but it's not very rational to use this option because how you want to know about the node number. The third and fourth one is about variable maximum and minimum. Obviously, if you want to find a minimum and maximum of a variable in a contour or in a section, you just need to use this option. For instance, I select variable minimum and create the location, select the location on the for example, wall shell. I want to find the minimum temperature point, so I select temperature from variable drop down list and then apply. As you can see, at the bottom of the shell, the temperature gets to its minimum value. The second option is point cloud. By using this one, I've got two options to make it from locations or from file. We start with from file option. By hiring this option, I need to import a txt file of point coordinate. Very simple. But the other option, from locations. When I use this option, I need to define a location for the software. For example, I want 100 randomly points on the wall shell to extract, for example, temperature on these points. So I select wall shell from locations and then select my sampling scheme, sampling method. Just like vectors, I've got different options, but I prefer the equality space because I want 100 points, point clouds on the wall shell. So if I apply, then you can see that there are 100 equally spaced points. Next one is line. It's very profitable option because whenever we want to extract a XY plot, we need to create a line first. And fortunately or not, we've got just one method. We need to define the beginning point of the line and the end point of the line. For example, if I choose in the y direction, the end point would be the last point, and apply it. by hiding point and point clouds, then you can see that I have created a line at the middle of the heat exchanger, and then for example I can plot the temperature on this line. But here is a point: we've got two line types. By default we use sample mode, and we need to enter a number of samples. For example, when I use 10 samples, it means that the line consists of or established by 10 points. So after extracting a plot on this line, there would be just 10 values, and it can't be sufficient. So by increasing this number, nothing would change here, but in the plot, the extracted plot I mean, it would be more accurate. And the other type is cut. When I use that, the line starts from the starting point and extend to the ending point. But when I use the cut line type, it would extend to the end point of the domain. I mean the last point that we have created a mesh grid. Now there would be no changes because we have extended the line to the last point, but let me reduce the Y and create a sample and then change it to the cut. Just to emphasize, the other tabs are just the same, so I skip them. You can change the color, even make it variable, or increase the line width, or the view options like rotation, translation, and reflection. Our next option in location is plane. It may be the most important tool for us. After creating a plane, we've got 5 different methods to define a plane. 3 of them dedicated to the basic coordinates like YZ, ZX, and XY plane. So imagine that I want to create a plane in XY coordinate. So I choose the method to XY and then the distance from the basic. By using a 0 value, there would be a middle plane, but with increasing this value I can define the distance from the middle plane. As you can see, the plane extended to the domain, so it is limited. If I want to create a specific one, I mean define the limitation by ourselves, we've got 2 options from plane bounds, a circular plane or a rectangular one. If I use a circular plane, then I should define the radius of it. By selecting 0.5 meter radius, then our domain limits to this plane, but the plane type is a slice here. If I use a sample one, then it would be my fully defined plane. And the other one is rectangular, just the same. I need to define the X size, Y size, and its angle, for example an oblique one. And the slice and sample is just like before, so I skip them and get to the 4th method. In 4th method we need to define a point, a basic point, and its normal. Normal means the vector which is perpendicular to the plane. Now you can see, if I change the coordinate of the normal vector, then the plane would be changed. And the last option is 3-point. It may become handy when you have a complicated or complex object or geometry and then wants to create a specific plane. So you need to define 3 corners of that and then apply that. Let me change a little to have a kind of weird one. Then you can see it's a specific plane and couldn't be established with other methods. By using volume, I can divide a specific volume of the geometry. First, I should define which element types I wanna consider. Obviously, we want all types. And then the method is a sphere. It means I should define a center point and the radius of the sphere. So let me increase the y value and then decrease the radius to have a full sphere here at the middle of the geometry. The type of the mode is intersection, below intersection and above intersection. By using intersection, the intersection between the sphere and the domain would be considered, and by choosing below intersection, the inner volume of the sphere, I mean the defined sphere, would be considered. And the above intersection consists of all domain except the sphere that we've defined. But because of our large domain, it may need a time. As you can see, the whole domain consists except the inner sphere. But let me change it to below intersection, not to waste time. And there is an option, inclusive. By using this option and below intersection option, the inner volume plus the intersection would be considered. Okay, let me delete the volume and get to one of the most important options in CFD post, isosurface. By making an isosurface, we need to define a variable and the value that we want to check. Let me explain more. For example, I want to check the for example temperature in the heat exchanger, and I want to check a specific temperature, for example 300 Kelvin if there is. So first I choose temperature from variable and then define 300 Kelvin for the value. By applying this, nothing will change because there is no place with 300 Kelvin, but for example for 550 Kelvin. As you can see, the software automatically detects and shows where the value of temperature becomes 550. Another application of this option, I mean isosurface, is to use a X, Y or Z plane. Instead of creating a plane and then make a contour on it, I create a, for example, plane here with y-axis of let me increase that to 0.5 or even more, 1 meter. Then from color, like before, I change the mode to variable and take a look at, for example, temperature on this plane. So it's kind of an easier way, instead of making a plane first and then create the contour. And another option is that I can change the value here and automatically the contour will update. Just imagine that you want to do the same thing with previous method, I mean creating a plane in different sections and then create the contours on them. It will take a lot more time. So gets to another option, isoclip. It's just like isosurface, but instead of defining a constant value, we define a range. We can define a range. So from locations, let me select a wall shell, the tube, and then I can create a new parameter. By selecting new, I should define a variable, for example, just like before, temperature, and define, for example, where the temperature gets above 500 Kelvin, and apply that. After a while and some calculation, the software will show where the temperature gets above 500 Kelvin, like this. But to make it more colorful, let's get to color tab and then select variable and temperature. And that's what we wanted. To continue, let me create a plane in y-z direction and then make a contour on it. So let me create that in y-z with at the middle, and then create a contour on plane 1. For example, the pressure, and with 11 number of contours. Okay, our important option in location is Polyline and user surface. By using Polyline, I can have 3 methods. The first method is from file. Like before, I can import a txt file, the coordinate file, and it is used for very complex geometries. Otherwise, we can make the lines in CFD post. The second option is boundary section. By using this option, I can select and define the intersection between 2 different boundaries. For example, the tubes and plane 1. I want to divide this region. So by applying that, and if I just hide the contour, then you can see the intersection of the tubes with plane 1 would be selected. And the other option is from contour. As you can see, I have defined a pressure contour on a plane 1 with 11 number of contours. So by selecting this, first I should define the contour. I have just one contour, and then select the contour level, which means, for example, in this contour I have 11 levels. By selecting, for example, the 4th level, then this value would be extracted like this. I hide the contour again, then you can see where the level of the contour gets to the 4th value, then it would be separated or in another level. The last one that we cover in location part is user surface. It is very similar to Polyline, but with a little difference. Just like before, we have a method of from file that we should import a coordination file, txt file. The other one is boundary intersection. For example, if I choose the tubes and plane 1, the intersection between them will be marked. As you can see, it is not a polyline anymore. It has a thickness, and the thickness is completely based on the mesh grid. The next option is from contour. If I have a contour exactly like before, we can have from contour and select the contour level, and then we will have the specific surfaces. The fourth option is transform surface. For example, if I have a surface name of plane 1, then I can have some transformations on it. For example, I can rotate it, I can translate or scale it. Just for an example, imagine the plane 1, and then if I apply a translation in x-axis, it was because I didn't select surface name. So if I put a value for x translation and apply that, then you can see I have a plane with a distance from the basic plane. The next option is just like this, offset from surface, but we can just have a translation. There is no scale or rotation anymore. And the other ones are not very applicable, so we skip them. Let me explain the last one, surface group. It's clear that with this option we can join different parts, I mean different planes. If I select location selector and then define plane 1 and another one like wall tube or wall tube shell and apply that, then I can have a surface group. I hide planes and polyline and use a surface. Then you can see I have joined a plane and another surface. So when I change the variable to, for example, temperature, I can have the temperature distribution along both of them at the same time because I have joined them. Just like this.